How you going, guys? Curtis from Cutting Edge Engineering. Today's job, we have an equalizer bar off a D11 Dozer in for a rebuild. What that means is we're going to be sandblasting and crack testing it, reclaiming the bores, fitting the new bearings and seals, and then we're going to give it a coat of paint. So we already know the customers had this sandblasted and crack tested before and there were no cracks detected, but because we are painting it, we want a nice clean surface, so we are going to re-sandblast it. And for our own quality assurance, we are going to crack test the no and fail points, just so we're 100% sure there are no cracks. And from a visual inspection, we already know that all of the bores need to be reclaimed. The center position is egg-shaped, and that is very common, considering that pin position carries a lot of the weight of the dozer, and they only run a fiber bush in there that is not greased, and by the time someone works out they are worn out, it's a little bit too late, and the bore is already damaged. And the outer positions aren't too far out of spec, but there are a few gouge marks in there where somebody has attempted to remove the bearing with an oxy torch and accidentally gouged a hole in the bore, so they will need to be reclaimed as well. So the first thing we're going to do is get this outside and get it set up for sandblasting. And to sandblast it, we're going to be using our Rapid Blast SD140 system, and the abrasive we're going to be using is 80 mesh river garnet. Now that we've got this sandblasted, I'm going to switch over to the wash mode and wash away all that material. So that's the surface cleaned up. Now we're going to get it back inside and crack test it. And the areas we're going to be crack testing are the bar ends, because we often see them crack through the grease hole, and also in the center position because that is the main load point, and we have seen these snapped in half. Before we crack test it, I'm going to remove the relief valve, the grease nipples, and all of the grub screws.
Uh-oh. Is that just Loctite?
Yep. And to crack test this, we're going to be using our Magnaflux NDT system, and we're going to be using a white background lacquer to spray on first, and then we'll use our black magnetic ink to expose any cracks. So we can confirm there are no cracks present, and that is a really good outcome. That means we don't have to do any crack repair. Generally, when there is a crack on an equalizer bar end or through the center, it is very visible. You don't even need to use the magnet to expose them, but it's just a surefire way that we haven't missed any. Now with that done, before we get it set up on the Zayer and start reclaiming the bores, I'm just going to clean out all of the grease ports to make it easier when we weld it.
Grease that came out. Lovely. Oh my god! I wasn't prepared. Mess. At least this was being greased.
Yeah. Now that's done, we can get this set up in the Zayer. To get this running parallel with the bed, I'm just going to square off the machine faces on the bar ends. So we're not going to be using our chain clamps on this setup because they were designed to be used with V-blocks. We're just going to use the standard threaded rod and bar to clamp this down. Now we need to find center of the center bore position, and because we've already got the specs and dimensions on the bar, we already know how far we need to traverse the table in order to get center of the outer bore positions. Now we've found center, we're going to bore this position, and to do that I'm going to be using a well-halter boring and facing head on our shop-made extended arbor. So I want to take about a 2mm depth of cut, so I'm just going to eyeball our start position and make any adjustments if I need to. So straight away I'm not happy with that. That depth of cut isn't enough, and I'm going to change out the insert, or we're just going to end up with a lot of stringy swarf wrapped around the head. So that is chipping exactly how we want it to. I'm just going to let that run and finish its cut. That bore is about 220mm deep, so it's a good thing we've got that extended arbor, which will give us the reach. So that's finished its cut, and unfortunately it didn't clean up all the way on that side, but I'm not going to machine out any more material because that would mean I would have to put an extra layer of weld in there. There should be enough coverage there with a single weld layer. If not, I can just add a little bit of extra weld by hand in that spot. So I have taken our first cut, but it's not quite enough, so I am going to take another one. But before I do that, I need to change the insert. Cutting through that area that had the gouge mark in it from the oxy has damaged it, so we're going to put in a fresh one. Now that position's done, we can traverse the table all the way to the other end and bore the other side. Now all the boring's completed, we can get it set up for welding. And because we do so many eye reclaims in the Zayer, a couple of months ago I did an upgrade, which saves us a lot of time during setups. And what I did was make a plate that bolts directly onto the head of the Zayer that I can mount the bore welder to and has a 250mm offset to the spindle. And that means I don't have to set up bearing mounts on each position and on every job, or move the bore welder from position to position. All I have to do is move the table 250mm and we're ready to bore weld. And to weld that, I'm using copper-free ER70S6 in a 0.9. And to back that up, I'm using Argo Shield Universal. I'm going to run that at about 18.5 volts and 4.5 meters of wire a minute. So that's our first bore welded. Now all I need to do is move the table till the digital readout reads 250, which is the offset from our original center position. And then we can start the bore welding again. But because this bore is 220mm deep and our line bore only has a feed of 200mm, it's going to require 2 setups. So that's our center position bore welded. I'm really happy with how that's turned out. Everything's nice and consistent. And now we can move our table across to the final position. So I've gone ahead and got our final position bore welded, and that is all of our welding completed. And we started with a fresh roll of wire, which was 18 kilo. We've gone through about a third of it, so that's about 6 kilo. And after all the welding, there is quite a lot of heat in the bar, so I'm going to let it cool down overnight. Now we got the bore welding set up out of the way, we're going to refit the boring head and start machining the bores. So I'm going to take our first roughing cut and then we'll take a measurement. The finish size I'm aiming for is 158.7 mil, which will give us 0.1 of a mil crush on our bearing. So I've taken our first measurement and we've got 0.25 of a mil to remove, but I'm going to do that in 2 cuts to reduce the risk of overcutting it. So I'm going to adjust the boring head out 0.1 of a mil, which is 0.2 overall. So that's our bore machine to spec. It is measuring spot on. The surface finish isn't as nice and shiny as I would like it to be, but it is still very smooth. On the other bar end, I will try a different insert and see if we can improve it. Now we're going to machine each face to true them up, and then we can cut the snap ring grooves. Now we can cut our snap ring grooves, and I'm going to be using a boring bar with a 4mm parting insert. And the purpose of the snap rings is to retain the bearing into the eye. And to work out our snap ring locations, first thing we do is take a measurement of the eye, which is 140.1mm. Then the width of the bearing is 88.1mm. The difference between those two is 52mm. We then divide that, which is 26. And then all we need to do is touch off on the eye, zero out the digital readout, feed down 26mm, and that is the location of our first snap ring. Now we've got that in position, we're going to set the feed rate on the boring head. And we need the snap ring groove to be about 4mm deep, so I'm just going to eyeball the depth and then we'll measure it. So that's our first groove cut. To cut the second groove, all I need to do is zero out the digital readout, feed down 92.1mm, which is the thickness of the bearing, plus the 4mm insert. Now with that done, all I need to do is cut the grease groove, and that will be directly in the middle of the two snap ring grooves. And the next thing we need to do is machine these two areas out to a diameter of 159.5 mil, and that will be for the grease seals. Half a mil. Now we need to cut the one on the bottom. Rather than take the tool out and have to set it up again, all I'm going to do is move the head so the tool has clearance to go through the bore. I can then line it up with the bottom snap ring groove, bring the head back out to its zero and make the cut.
Oh, that was close.
And the last thing we need to do on this bore is chamfer the top and bottom faces, and to do that I'm going to be using an S&MG neutral. So that's our first bore machine to spec. Really happy with how it turned out. Now we can move on to doing the center. So this position is for the woven fibre bush because it doesn't need snap rings to retain it or grease to lubricate it. It is just a straight through bore, and we need to machine that to 152.2 mil. While that's boring, we're going to drill out the holes on the first bar end for the grease ports. Drilling these can be very challenging for a number of reasons. One of them is you are trying to drill into a 4mm snap ring groove, and that can lead to broken drill bits. You're also trying to drill through the weld material, and it can get quite hard. You can also run into weld spatter that gets trapped down the hole, which will also lead to broken drill bits. But this is by far the best way of doing it. If you were trying to drill the grease holes first and then cut a snap ring groove through that, you would end up with a lot more broken tooling.
Here we go.
The hole.
There we go.
And then the punch back. So that last one has given me a lot of trouble. I've sharpened that drill about 5 times now. So I'm going to do something a little bit unconventional, and I'm going to intentionally blunten the drill by grinding off the sharp cutting edge.
It's working. So that's machined to size. Now we need to face and chamfer the top edge. Unfortunately, we can't reach the bottom face with the boring head, so we're just going to have to do that with the grinder when we get this out of the mill. That's our center board done. Now we're going to move across to our final position. And because it's the exact same as the other end, I've already gone ahead and got that completed. So that's all the work completed in the Zayer, but we are not done with this yet. Now what we need to do is get it over to the welding area so I can grind the other side of the center position. I'm also just going to remove that sharp edge using a Noga deburring tool. I'm just going to give it a final clean up with a wire wheel. There are two more grease ports that we need to re-drill. These actually go through the bar into the bar ends, and these are commonly used when the machine is set up with auto greasing. And to drill it, we're going to be using a long series 8mm parabolic drill. Whee.
Nice.
So that was successful. Before we start installing new parts, we need to make sure there are no burrs or swarf trapped in the snap ring grooves. So I'm just going to chamfer all of the grease ports using a 90-degree air drill with a countersinking bit. And I'm just going to run a flapper wheel around the bores to remove any burrs off the surface. And now we can start to install our snap rings and our seals. Now we can get this over to the press and press in the bearings and the rest of our seals. Before I paint it, I am going to mask off all of the seals and the bearings. It is a little bit of extra work, but I prefer to leave painting until last. That way I don't damage the paintwork when I'm trying to install seals or bearings in the press. To help protect the metal and give our top coat something to adhere to, I'm going to be applying an etch primer. And now we're going to go in with our quick dry enamel top coat in cat yellow. And hopefully this is going to be one of the last times we are painting outside and using enamel paint. You've probably seen in the background our new side opening high cube 20-foot shipping container. We're going to be setting that up into a proper spray booth. And that's going to allow us to use 2-pack paint, which is going to give us a better end result and is a far harder wearing paint than enamel. Not only that, that's going to eliminate the constant issues we have with the weather and getting things painted. It was definitely an investment we needed to make and something I'm looking forward to having set up. Righto guys, so that's all the painting completed and we've let that dry overnight and I'm really happy with how it turned out. It looks like a brand new equalizer bar again, and this is definitely a very cost-effective option for our customer, even though we had to reclaim all 3 bores. If he was to go and buy a new one from the OEM, it would set him back about $56,000. And I'm just going to touch up the areas where it was sitting on the trestles with some spray paint, then I can strap it down to the pallet and get it back to our customer. Hope you enjoyed seeing this rebuild. Thanks for watching. Good thoughts. Good thoughts. Good thoughts. So that's all the surface cleaned up. Now we're going to get... Because that is where they are known to fail and... Because... Oh, fuck. No. And the areas we're going to be... Oh, fuck me. And because we do so many... Oh, fuck me. I'm just going to run a flap over it. Oh, fuck me. No, let's stop and say it again. It's too much confusion. And I'm going to change out the insert to something that's going to break that swarf. Otherwise, we're just going to end up with a big furry mess.
Big furry mess. Really?
First up, I'm going to be... Oh my fucking...
What is happening?
I don't know.
Stop it.
Okay, please, it's fucking hot standing in the sun.
Go in the shade.
I can't.
Why can't
You're standing
you?
there.
Wow.
Oh, that's better.
Let's see if that improves things.
Righto. First, I'm going to be applying it at...
No, I didn't.
And hopefully this is going to be one of the Oh my fucking god.
Do you need water?
No.
55, 6, 7, 8 point...
6'9".
6'9", yeah, that's what I was going to say. What are you doing?
I need to fucking see, man. Like, fire it back the other way this time.
Into the bore?
Yeah.
Yeah, okay. Probably be
Just
easier
spray
to
it.
clean. Well, hang on.
Catch it.
Hang on. Let me... Which side should I see?
That side. Oh my god.
Is it everywhere?
Yeah.
On me?
Yeah, on your face.
I did have a thought before you did it. This isn't going to end well.
It's on your face.
It's everywhere. What? Whose idea was that?
You fucking one of the first one.
Oh wait, that's my shadow. Did you kill it? Oh, poor piggy. You're a clever boy. You killed it.